Shall we begin?
Yes, Ritika, I think let's we can just get started.
Sure. Welcome, everyone. So, I'm Ritika and I handle product marketing here at Astra Security. And thrilled to have all of you here today join this session. And we will be deep diving into some of the major API breaches that shook the world and how they could have been prevented. So, joining me here today are two brilliant folks from our engineering team. So, introducing Sunil. He's our engineering manager, and prior to Astra, he had co-founded a collaboration platform called Prakya, and he brings years of experience scaling software development platforms. And we have Nandan here, who's our SDE too. And before Astra, he was a part of Open Text, and he's one of the key contributors in building the API security platform. So I'll not take much of your time. So over to you, Sunil.
Thanks a lot, Ritika. I'll just share my screen. Just give me a minute. Okay, let me know if my screen is visible.
Yes, we can see your screen, Sunil.
All right, let's get started. Thanks for the introduction, Ritika. Hey everyone, thanks so much for joining today. I'm really excited for to deep dive into a topic that's become almost invisible yet so critical in the way that online works. That is APIs. So APIs are quietly running nearly everything that we do, like sending messages or receiving those timely notifications or alerts from making payments or to streaming content. They have become the invisible glue of the digital world today. But the problem with that invisibility is also it makes it one of the biggest blind spots in security. Um, Most of the worst API breaches that has happened were not caused due to super complex zero-day exploits or sophisticated hacks. They happen really because of simple things like one of those forgotten endpoints or misconfigured permission or higher escalated privilege access, or maybe some of those endpoints that revealed too much of information that wasn't required. So today we are going to uncover some of these real incidents, look at those patterns behind those incidents, and most importantly, talk how Astra's API security platform can prevent such incidents proactively. So to put things into perspective, um, we all know that APIs have become the foundational or the backbone for most of the applications that we use these days. They are no longer the data connectors, but it is a language that modern systems talk and get work done. Um, for enterprises these days, 1.5 billion API calls on an annual basis is a norm. Uh, that is incredible amount of data that is being sent back and forth for each and every single day. Uh, the concerning part about that is while the adoption of APIs have exploded rapidly, visibility hasn't kept up, and there's a significant gap in that space. While organizations agree or admit that they are not fully aware or they do not have a holistic view of all the API endpoints or the inventories that is in production. We call those as shadows or zombie APIs, the ones that are typically deployed and forgotten. Um, they are not actively monitored, they are not tracked, and worst case, they are not even being patched on a regular basis. But they're silently running there, catering to traffic. And it is these endpoints that typically become hotspots for what attackers are typically looking for. Now, since we spoke about these blind spots or hotspots for attackers, let's quickly touch upon these real life incidents that have happened in this past with some of the enterprises. To begin with, Peloton, where there was an API breach and most of the customers' data was available in public. Some sensitive information like social security numbers also were breached. Talking about Optus, which is a telecom company, there was a misconfigured API endpoint that potentially led to a leak of 10 million records. So is T-Mobile, another telecom player. But in that case, it was a staggering number of up north of 37 million records, customer records that were exposed. We all live in the digital world where we rely on different API providers. MOVEit is also a similar file transfer solution provider, and one of their breaches also exposed a lot of their customers' data also. Close to 200, 2.5K organizations were exposed due to that breach. So these weren't typically edge cases that we're talking about, but these were just normal systems. These were APIs that were deployed to production, catering to traffic. But one of those blind spots got exposed, which revealed this humongous amount of customer data. So if you now look at it and map it back to OS top 10 list, there is no sophisticated hacks or anything that's happened, but it's very simple things over and over again were repeated, like a broken authorization or a poor inventory management of your APIs or unsafe consumption of API endpoints without the right access controls. Um, What's worrying with these is these are not found upfront during a testing or a development phase, but unfortunately, these are revealed when the damage is done by attackers. So it is evident that traditional security tools that are built, they don't understand API behavior. They don't see what is at a logical or they don't flag what are the errors. What's needed or the need of the hour is not a tool that superficially scans for API endpoints, but much more layered in approach that can look at APIs in a much more holistic way, which is what primarily we at Astra have built the API security platform for. So I'll just take a moment now and briefly touch about these real incidents that have happened and how potentially our API security platform could have help the customers uncovered much earlier. So the issue with Peloton was an unauthenticated API access. Astra would have flagged those endpoints much earlier when there was a scan happening for those API targets and flagged it to customers at a very early stage, much before a release is done. Similarly, for Optus, sensitive information or any PII data, or if there is an endpoint which needs some sort of a rate limiting, is very evidently flagged by Astra's API security platform. And if it also suggests if there's any redaction or extra layer of tokenization that is needed, with T-Mobile as well, we have wherein the customer records were getting leaked. With Astra's real-time observability, we have the ability to know what is an misconfigured endpoint, and also if you're not aligned with your inventory, Astra can catch those much early on and kind of display it in your inventory book. Similarly is the case for MOVEit as well, wherein we have the capability to continuously observe what is the endpoints that is being used and also detect and potentially flag those as well. So the since we've spoken about all these incidents, it is evident from all of these. This could have been easily avoided if we have a single source of truth for all the API endpoints, and what is the layers of protection or the suggestions that a platform like Astra can provide, whether it needs rate limiting, whether it flags what are the list of unauthenticated endpoints, what is the PII that has been discovered. So, having said that, I will pass on to Nandan, who will also get us into this demo and show us the real working of the API security platform. Over to you, Nandan.
Yeah, thanks, Sunil. Sharing my screen. Is my screen visible?
Yes.
Yes, Nandan.
Cool. Great. Thanks, Sunil. So, welcome everyone. Yeah, so at Astra, our motto for the API security platform is simple. You cannot secure what you can't see. I would like to agree with Sunil and would be emphasizing the same that APIs have become the backbone of modern applications, connecting services, partners, and then customers. But as teams move faster, visibility becomes the first casualty. Most organizations don't actually know how many APIs they have, or for that matter, how many unauthenticated APIs are sitting in the infrastructure, or what data those APIs expose or interact with, and how securely, yeah, at the end of the day, how securely they are being used. Yeah, so that's the first problem we wanted to solve. To address this blind spot challenge, so that is the reason we have built the API inventory. It has all this information, all of your endpoints, probably, yeah. It has all of your endpoints along with authentication details, and then along with all the parameters, basically everything to put into together everything, the risk classification, the vulnerabilities that are associated with an endpoint. Yeah, so that is whatever you need to measure the security posture of an endpoint. You basically have all these details. We'll go through all these things in detail in a while, but before that, I said like API inventory is being the key. Now, how do we get into an API inventory? So the journey to create the API inventory, or to build the API inventory, will start from observability. And in order to do that, Astra provides different mechanism or different ways of observing the inventory. So first one is via the Postman or the Open API, or also known as Swagger specification files, where during the setup of the target, one can provide these specifications, and using which we will build the inventory corresponding every API, or every endpoint or parameter will be mapped to the inventory, and then that will lead to the scanning as well. This is one way. But the catch here is that it is always not possible to be up to date with respect to the specification file. And that's where Astra gets more powerful as well in terms of its observability. So Astra provides traffic connectors, or in other words, the integrations, which basically observes the traffic that is happening in the user's infrastructure, and then it will help to build the inventory in the near real time. So here the advantage is that the information is always up to date. Astra ships different integrations specific to the infrastructure, whether it could be Nginx, AWS, or the GCP infra, or you can have AWS specific gateway or RPG gateway, once again shipped by GCP. Then Kong, Azure. HTO. So yeah, we have multiple integrations in order to cover wide variety of infrastructure. And finally, we also provide uh, the man in the middle proxy kind of an instrumentation with which you can work with your existing API testing applications, like whether it could be Postman or whether it could be Burp. Then there is Hopscotch, Curl, or even the browser as well. So this is basically a developer-friendly instrumentation which will work in a plug-and-play mode, where you can uh, work with it in order to cover or capture the APIs that you are testing with, and that will also help to build the inventory. All right, cool. So these are the different integrations that help to build the inventory. Now, what is inventory? So inventory, if I want to dig more deeper into this, inventory is it is at the heart of our platform. That is our API security platform. It offers a single pane view of all of your endpoints across your infrastructure, right? So this solves the first or the foundation, I would like to call it as a foundational problem of the visibility. So that's where we said, like, you cannot secure what you can't see. Yeah, of course, this offers a single pane view of all the information, which I showed earlier as well. For example, it could be tracking with respect to different parameters, um, request headers, basically the headers, query, the path parameters, then the request body, response body, absolutely everything. So we keep track of everything. Then, along with this, we also provide the risk classification. Now, why do we need the risk classification? There are different risks that can be associated with an endpoint: shadow, orphan, zombie, and then the sensitive information leak as well. We will see each of them in detail. Let's start with the unauthenticated APIs. For example, these are the APIs which, as per their authorization structure, they are not following any authentication. So they are basically unauthenticated, and uh, they are exposed to the outside world unauthenticated. For example, this is the endpoint. API v2 search is what it says, and this is an unauthenticated API because it often doesn't have any cookie or basically any authorization. Now it also takes in, I mean, as per purely relying on this information, it takes in a parameter for an user's email, and then it will return certain information based on this. Now the problem is, now this is easily exploitable authorization issue, because if it can be first with the different emails, then it can provide PII leaks. Now, talking about the PII, that brings very important, the sensitive information leak. For example, uh, any medtech or fintech domains for whom regulating the PII is always part of a compliance, and any leak in there, it will be very much bad for them, both in terms of business as well as from the reputation side, because the domain is as such. So, so what are the sensitive leaks? So it is not like, just calling it as this PI, this endpoint is leaking PII or something. We also reveal, like, um, what is the evidence that we have identified in order to call for an API, for a PII leak. For example, let me open any one of these endpoints. And yeah, so here you can see that there is a response body which is saying that, like, what is the credit information found. So this could be the one of the PII leak. Talking about the next set of risk, that is the zombie API. Of course, the most haunted risk among the different APIs. The reason being that these are the deprecated versions of the APIs. For example, often there is a chance of, whenever there is a V3 version out, then V2 version, one cannot deprecate it immediately from the application per se. Having said that, they are needed for the backward compatibility, so that's why they will still remain in the infrastructure. But how long, that is a question. So ideally speaking, all the security measures should be applied on the zombie APIs as well, but often they get missed out because always, almost always the attention is with the new kit, that is the V3 version. The problem is that if they are leaking any sensitive informations, or they can be often exploitable as well, because the moment one sees the V3 or V2 version of the API, then the obvious question for an attacker is going to be, does it have the V1 version or the lower version as well? Can I fire the request with the V1 version and see what is going to be the result? So that always opens up a new attack vector, because in the name itself it is often very conclusive that it has a version. Talking about the shadow and orphan API, shadow APIs are the APIs which are undocumented. That means, um, if if an IT governance uh, if an IT governance section, or if CISO wants to apply certain regulations with respect to all the APIs, then they need to have, like, what are the different APIs that I'm having in my environment or in my infrastructure. So the APIs always come with certain standard documentation. Now, Open API or Swagger being the industry-wide accepted standard for API documentation. So yeah, often these APIs, when they are new, they are missed out from the documentation, and then yes, of course, that is the first problem in the visibility. Orphan APIs, so these are the APIs uh, which are there in the production, but they receive the request here and there. Like for example, once in 10 days, or once in whatever X number of days. The problem is that they have their own attack vector, because of course it's a normal tendency that if I'm having the API which is consuming more load, or something attention grabbing. So if that is the case, there is always there are two eyes on top of that, maybe more than two eyes on top of that, in order to see how it is performing with respect to security, everything. But if it is not observing the traffic, so that means, yeah, often it might be getting um, it might be getting ignored with respect to the security controls. Yeah, so hence opening up the different attack vector all along. Oh yes, and finally, last but not the least, schema detection as well. So now the change in the schema detection, for example, let's take any one of the endpoint, and if it suddenly starts accepting a different different data type, where it was supposed to take in some other parameter. For example, yeah. So as you can see, so this, as per the specification, it says that it is supposed to accept the integer, but whatever is being observed, it's a string. So this kind of schema mismatch or drift in the schema, so that can occur, and it can have the consequences with respect to impacting the business logic of the application code, or it can also open up the potential for the injection kind of an attack. So yes, Astra continuously observes the drift in the schema, and it will also offer in a way in order to um, run the continuous scanning on only those endpoints for which there is a change in schema. We'll see that now. Along with this API inventory and the risk classification, the API security platform shipped by Astra is always backed up with a dash scanner, which consists of 15K plus rules, in order to CV rules, in order to detect the API related vulnerabilities, and it is always up to date. Yeah, so then there is another option in the scan that is called as a delta mode, which will only scan those endpoints which have been changed since of the last scan. So this is where the schema drift, which we always observe, will come often very handy. That if there is any change in the APIs, that will be automatically detected, uh, and also the scan can only be run, the scheduled scan or the automated scan can only be run on those endpoints as well. We will, having said that, we will now take a look at some of the vulnerabilities that are reported for these targets by our scanner. So we perform different kind of detection, right, including from injection, the PII disclosure, or it could be denial of service, authentication misconfigurations, and then yeah, again, once again, this is a authentication related configuration, and then information disclosure. So yes, so there are various kind of detection that we run. Finally, to cap it off, we are also working on integrating AI or leveraging AI in terms of detection in order to reduce the false positives, and then also um, improvise on the different area of API specific detection, whether it could be authorization, let's say BOLA. So broken object level authorization. So that is something we have, but also that in order to bring in that new generation, or um, uh, in order to bring in the more contextual based detection. So that is where yeah, we are also working on in order to bring in the bola detection as well. All right, cool. Call to action would be to have your target API target, configure the authentication, observe your API endpoints, run your first scan, and yeah, if there are any vulnerabilities, um, definitely there will be because um, in the world of security, of course, here or there we will often end up missing certain configuration related, or kind of leaving it open to some or the other attack surface. And yeah, that will be the first step to fix those vulnerabilities and improve the security posture.
That's great. Thanks a lot, Nandan. And I think we are open to questions. Um, so Nandan, meanwhile, we get any, can you also just talk about what are the various authentications that while setting up a target, right? What do we support in the platform?
Yeah, definitely. So uh, the Astra's API target, it's sorry, it supports various kind of authentication ranging from basic auth, all the standards basically, OAuth, then the JWTs, then the bearer token or the API key. But often what we have found is that different application will have different uh, way of authenticating, and there will be a different standard. So we also, that is the reason we also provide a customization with respect to the authentication as well, those retaining the flexibility. So uh, if the authentication of my API is not going to fall directly into any of these buckets or these categories provided by the platform, then we can always have our own script where we can define the custom the authentication format that we want, so that we are going to honor it and fetch the authentication token which is required for the scan. So yes, we proud to say that support almost all kind of authentication out there.
Nice. And also, if we can just probably talk a little more of like when can for the audience, like can we just also touch upon like when do we need to go for integrations, or when can I say okay, my Postman or my API spec would suffice for now to get started.
Yeah, definitely. For example, um, maybe take this target itself. Uh, Assume that I have the open API spec file, or to that matter, even the Postman collection as well. So basically, the problem here is that as and when, even if I assume that I have the up-to-date Postman collection as of now, that statement is may not be going to remain the same when and where my application grows up, because there will be need of more APIs, and also the existing APIs contract might be getting changed. In such cases, it is not always possible to keep updating my specification and keep uploading it. That's the reason where the integrations comes in handy. The difference between uploading the postman or the spec file compared to having a integration is that, so we will be having the flexibility to not only um, to not only observe the real-time traffic, which are more worthier than mock production, postman-related requests. That is not the only thing, but also is that I need never bother about what are the new APIs getting into my system, or whether
Got
any
it.
of my API schema is changing, because they are always going to be observed.
Okay, great.
Yeah, as a starter, one can always start with OpenAPI or the Postman specifications, and then use them to import the endpoints present in those spec to the inventory.
Sure, and then also I think if like we are talking about the usage of AI and more of contextual detections, uh, throw some light like what could that mean for the audience?
Yeah. Um, so let's take an example where um, you know um, how the contextual detection can be done using the AI. For example, let's take a typical example on the Bola itself. That's what I spoke about earlier as well. Uh, there is going to be some user ID on which it is running. For example, if I take this as an example, as you can see here, if you look at my tab, so it says I'm going to open an HTTP endpoint belonging to this ID. So that means it is not only about authentication. The user with which I have logged in, it also has the authorization in order to view this particular endpoint. Now the question is,
Right.
um, if I am logged in as a different user, then do I have the access as to view this endpoint or not? Because authentication is, of course, logging into your system, but authorization is where you will be checked whether you have the access on the resource, of, whether you are having the access for the action that you are trying to do on the resource. So this is where the contextual information comes handy, that what your application is about, and then what are the different roles present. For example, I might be logging in as an admin user, and then there will be someone with a role of use as a restricted user, or an full member, or something like that, delivery role. And then there will be something called as customer role. Different roles will be there. So when you are accessing the application with those roles, are you going to able to access the endpoint, and then are you able to perform the same level of um, uh, same action on that resource that um, than the intended uh, role or not? So that's where we talk about the victim role and the um, uh, attacking role. Yeah. So this is with respect to the privilege escalation. Now let us take the same example to the IDOR as well. Um, there can be order. I think there was an endpoint earlier which was having some order IDs. If
Mhm.
can I access the order ID belonging to some other user, if it was mapped with an integer, or if it was mapped with a slug? For example, if I was actually I showed that there was an endpoint which was using the username. For that, it was take user as a email address. Can I use the different emails and check whether there is an access for those or not? For example, admin at that particular domain.com. So yeah, so these are the IDOR attacks. So for these things, um, there needs to be a contextual information.
Got it. So what we layer is like more of contextual aware endpoints, and based on that, the payloads or the testing will keep changing, right? So
Yeah,
basically, it's kind of contextual how the system is observing and doing. Great.
yeah.
Um, Nice. Any note on like we touched upon PII, because like again uh, what would it mean like for customers like who are using our platform? Uh, what about their PII data? Like how does that get protected? Like is there anything that we can talk about?
Yeah, so for example, we spoke about observability as well. Uh, so often, what happens is, let's consider that example only. For example, uh, I'm the user with who is running a medtech application where I want to detect if there are any my APIs which are giving out the PIIs, but at the same time, there is a complaint for me as well that the PIIs they are not supposed to uh, uh, get out of my infrastructure. In such cases, during the employment of the integration itself, we offer the flexibility to redact the PIIs and then send it to the Astra. So in that way, the PIIs are also will be getting detected, and they will also not be leaking, at least in terms of detection. And then once the
Got it.
PII, let's assume that, for example, this endpoint only, if the PII is fixed, and after fixing, when we observe this endpoint again, if we do not see this PII anymore, then we will remove it from the risk classification.
Got it. Um, Yeah, folks, like if anybody from the audience, we are ready to take on any more questions, anything on API security or the platform, or what is it we are kind of excited about the next one.
We have a
So
question.
yes,
We have a question from Akash. So he's asking, how do you validate false positives before reporting? And is there any human verification step?
yes, Akash. So we do have a triager that we are working on, which basically for every detection that we have, we kind of look at it from a perspective of a system like that. We are talking about contextual information, right? So we derive the right context out of it and also see if they are really vulnerable, what the system has claimed to be. And based on that, before it reaches the dashboard or before it's going to the customer's dashboard, there is one good level of triaging that is undergone, and that will be reported if it is like a true positive or a false positive. So it's completely driven by AI at the moment, but we are also putting in the right set of controls to see where the human in the loop will come in and has always a way to override that decision that the AI has taken. I hope that answers the question, Akash. And I see somebody else has also raised a hand. Sudarshan?
Yeah, my question primarily is in payment companies, like how would you test production APIs safely, because, you have continuous work happening always.
Yeah, maybe Nandan, you want to take that?
Yeah, so always, yeah, of course, in terms of, so I would like to understand one thing. Is it in terms of APIs receiving more load if in case the dash scanner supplies, or how? Like, I didn't get the question properly.
Yeah, so see what happens is typically, see, there could be non-intrusive monitoring, then there could be synthetic transactions and all that. But
Hmm.
so all these things would still call for, latency, then uptime and all that, So
Correct.
yeah, so how do you manage when you have this tool which you are going to introduce, taking care of some of these kind of challenges?
Yeah. So first thing is that in terms of production scenario, we often do not ask for the credential in order to run the authenticated testing. But having said that, even if we talk about a non-production scenario, or even in case of authenticated production scenario itself, so we have something called a scan speed with respect to the automated scanning, where one can control whether it should operate in the normal or the slow mode or the fast mode, so that um, the requests sent out by the dash scanners are always spread out over the time, so that um, it is going to be from the performance wise for the server. It is going to be just one more API request that it has to serve, so that um, uh, the performance of the server is also something which is taken care of.
So to add to yours, also, will you, or is it possible that you can also mirror the same production scenario
Oh,
and
definitely,
and
definitely.
do similar testing?
Yeah. So if the APIs are going to be same, for example, let's say that we are going to use the integrations or the observability from the production side, and then using those requests, can we scan the staging or pre-production or the QA kind of an environment? So that is something feasible as well, but it also depends upon whether the same requests which are observed from the production, can it be used, or whether it can be replayed in order to get a success response or not. Yeah, it depends, but yeah, it is possible.
Okay, thanks, Anand.
Yeah, thank you.
Do we have any more questions? If not, I'm proceeding with the conclusion. I'm sharing screen. Is my screen visible, guys?
Yes.
Yes, Ritika.
Yeah.
Sure. So, those who all have been associated with Astra or know about Astra knows that our larger vision is to become a single source of truth for security. And we're building a continuous offensive security platform that brings every layer of security under one roof. So, as we can see on the screen, we currently have four offerings: a PTAS platform that delivers AI-powered continuous pen tests that are validated by our in-house certified security experts. And we also have a web dash scanner that performs authenticated vulnerability scans, and we cater to 15,000 plus test cases as of now. And the API security platform that we just learned about, and we also have a cloud security platform that so we are all set to launch the cloud security platform. uh, like it will be launched in a month or so. We have soft launched it now, and it caters to all major cloud platforms currently, namely AWS, GCP, and Azure. uh, And lastly, I would love to share some recognition and accreditations that we have earned along the way. So, first of all, we are a PCI approved scanning vendor, and we are one of the 86 companies out there who are a PCI ASV. And we are certain in panel. We have CREST certification, ISO, as well as we recently got a SOC 2 certification as well. And our pen testers are also certified, as we can see on the screen right now. And moving on, we had recently launched the API security platform on Product Hunt, and like with the recognition and the love that we received from our users, we were able to earn third product of the day. And we also earned the title of fall leader in 2025 by G2. And and we are catering to 1,000+ customers right now across 73 different countries. And with that, I would love to wrap this up and thank you everyone once again for joining us today. And we really hope that this session gave you a deeper look into how API breaches happen and how Astra is actually helping companies stay ahead of them. So if we don't have any questions, we can conclude.
Thanks a lot, folks, for joining. Have a good night.
Thanks a lot, Sunil, and thanks a lot, everybody. Bye bye.
Thank you,
Thank
everyone.
you. Bye bye.
Thank you for joining. Bye bye.
Thank you, everyone.